How did I write this one?
Okay. So we ended class yesterday talking about the inverse trig functions, secant, cosecant, and cotangent. All right? So I want to start by doing an example so you're aware or have at least seen how I could ask you to do a problem using those trig functions. So, all right, so here's our first example. If cosine is equal to 3/4, cosine of theta is 3/4. Find secant of theta. It'd just be 4/3. Yep. So remember, to go from cosine to secant, you just do the reciprocal.
So that's the
That's the answer.
that no
4/3. There's nothing else you have to do there. Nope, that's it. Now,
I like these problems.
Yeah, right now.
okay. Now, I could also give you one angle like that and say find all 6. Okay? So if I did that and said, okay, if cosine is 3/4, find the rest of the trig functions. So then what you would have to do is draw a right triangle. Okay? So you know this is opposite, adjacent, hypotenuse. And we know that cosine is ka in SOHCAHTOA, correct?
Hypotenuse is 4, adjacent is 3.
Yes. So hypotenuse is 4, the adjacent is 3. We get that from cosine, because cosine is A over H. So,
Minus 9 is 7. Square root of 7.
yes. So now we have to find the opposite side using Pythagorean theorem. So you would do 3 squared plus b squared equals 4 squared. 3 squared is 9. B squared is, or 4 squared is 16. Now I got to solve for b squared. So b squared is 7. So then b is the square root of 7. Then once you have all 3 sides, is finding the other trig ratio is very difficult. So then, you already know cosine. So, cosine we already know is 3/4, which then means secant is 4/3. That part's pretty easy. Huh? Why am I going so fast? I don't know. I'm not trying to.
So sine would be square root of 7 over 4.
Yeah. So if we're using SOHCAHTOA, sine is opposite over hypotenuse. Opposite side is square root of 7. Hypotenuse is 4. We already know cosine and secant from the problem above.
How do you write the cosecant?
CSC. Okay? Then tangent is what? Square root of 7 over 3. So then, all I have left to find is cosecant and cotangent.
4 square root of 7 over 7.
Yes, 4 square root 7 over 7. Now, if you're wondering how did they get that, remember, you flip it. So it becomes 4 over the square root of 7. But I can't leave a radical in the denominator, right? So you got to multiply top and bottom by that denominator, which is the square root of 7. So I get 4 square root 7 over the square root of 49. The square root of 49 is 7. Cotan, same thing. If you flip it, it's 3 over the square root of 7. But again, you can't leave a radical in the denominator. So you end up with 3 square root 7 over 7. Okay? So that, if I said find all trig functions and I give you one value, that's how you do it. Draw the triangle, use Pythagorean theorem, find the missing side, and then just plug it into the ratios. SOHCAHTOA. And then flip them. Make sense?
Okay.
Is that terribly difficult?
It actually makes a lot of sense,
Okay.
surprisingly.
Now, what if I give you one that's a decimal?
Don't do that. It'd be better if you just didn't.
Okay? If cosecant equals 1.345, find sine of theta. So,
3.1.
how are we getting that?
What is 3.45?
Flip it. Make it into
It's
a
just
fraction.
it's just that any decimal.
Make it a fraction.
So, cosecant is 1.345 over 1. So then if I want sine, what is sine in relation to cosecant? They're opposite, they're inverses. And how do I find that inverse? I just
Flip it.
flip it. So 1 divided by 1.345,
That's
which is 0.7435.
wow, is there any way we could simplify? And not have it be that?
No.
Okay.
If I give it to you as a decimal, that's all you have to do. What was your question, Tines?
What's the point of the opposite ones, opposite reciprocals, secant, cosecant?
So there's times that sine, cosine, and tangent won't give you what you're wanting. So that's when we use secant, cosecant,
Are
cotangent.
they on the calculator?
Yes. So, well, no, but yes. You just do 1 divided by whatever, sine. So like if you want to find cosecant of 1.345, you just have to do 1 divided by sine of 1.345. Does that make sense?
Yep.
Any questions on that? Okay. All right. Last thing here. So, if we think back to geometry, when you learn trig in geometry, and actually when you learned about right triangles and finding side lengths,
These will they equal each other?
one of them, yeah. So you learned about special right triangles, okay? And there are 2 special right triangles we're going to talk about. I don't know if you remember those or not. 45, 45, 90,
Yes.
and 30, 60, 90.
Yep, I remember completely.
Okay? So, when you learn these, you learn that if we have a 45, 45, 90 right triangle, what do you know about the base legs? The legs opposite the 45-degree angles. They're the same length. So those are both, we just say those are both n. Okay? And then do we remember what the ratio was or what we multiplied n by to get our hypotenuse? You're close. Square root of 2. Okay? Do we remember that? Is that ringing a bell now? 45, 45, 90 is n square root 2. Okay? And again, the reason our legs are the same length is their corresponding angles are the same size. It's just like when you're looking for a side length the bigger the angle, the bigger the side. Because the bigger the angle, that means the wider the opening. The wider the opening, the longer the opposite side has to be. Okay, then we have 30, 60, 90. So, looking at a 30, 60, 90 right triangle, what side should be the shortest? The side opposite of what? Yep, we call that side N. What side should be the longest? The hypotenuse, which is 2N. And then the last side, bless you, side opposite 60 is N squared 3. Is N squared 3. Okay. Now, you may be wondering, okay, what's the point of reviewing that? Well, we are going to start learning the unit circle. Okay? The unit circle, which has all the key values for cosine and sine, okay, as we go around our one rotation. And there are 3 key values in each quadrant. And those key values are all factors of 30, 45, 60. 30, 45, and 60. So what we're going to talk about here real quickly is how you find sine, cosine, and tan values for those ratios. All right, so now, if I want to find sine of 30 degrees, sine of 30 degrees, and I look at the 30, 60, 90 right triangle, the 30, 60, 90 right triangle, what is the ratio of sine by SOHCAHTOA? It's opposite over adjacent, or opposite over hypotenuse, right? So if I treat that as my reference angle, then N would be my opposite side, right? And 2N would be my hypotenuse. Everybody with me there? So if I divide that, N divided by 2N, that tells me sine of 30 degrees is just 1/2. Because the ends would cancel each other out. Everybody see how I got that? N divided by 2N is 1/2. Because the N and the N will cancel each other out. We good there? Okay. How about cosine of 30 degrees? Well, if N is the opposite side, then N squared 3 is the adjacent side. So I would do N squared root 3 over 2N, and again, the N's would cancel. So what is cosine of 30 going to be? Square root of 3 over 2. Because if I write that out, I have N square root 3 divided by 2N, right? Adjacent over hypotenuse. And then I can just say, okay, N's gone, square root 3 over 2. You with me so far? How about tangent of 30 degrees? Opposite over adjacent. So I have N divided by N square root 3. So that becomes 1 over square root 3. But can I leave that?
No.
So it's
It's going to be 1 square root 3 over 3.
Square root of 3 over 3. Yep, perfect. You don't need the 1 out front. Okay? Well, when we get to talking about the unit circle here a little bit later on, you just found that first quadrant point. The ratio at 30 is sine is half, cosine is square root 3 over 2. Now, from that, can I find cosecant? If sine is half, what is cosecant? 2. 2 over 1 or 2, same thing. What is secant?
2 square root of 3 over 3.
2 square root 3 over 3. Now, I will tell you with tangent, the reason I wrote down 1 over the square root of 3, that's the actual ratio. I'd rather flip that than this, right? Because if I flip 1 over the square root of 3, I get that that's square root of 3. If I take it from here, then I get 3 over the square root of 3. I have to rationalize it again, and I end up getting the exact same thing. Okay? So when you're working with any of them that have a square root on the bottom, when you go to find the reciprocal or the inverse, go back to the original before you rationalized it, because it'll make it easier to find the inverse. All right, so we're done with 30. Now we have to do the same thing with 60. We're going to jump down to 60, so we're in the same triangle. So now what's the opposite side? N square root 3, right? And then the adjacent side, the hypotenuse. So, can we move a little bit quicker through this now that we've seen how the process works? Okay. So, n square root 3 over hypotenuse, 2n, gives me square root 3 over 2. Okay? Cosine, adjacent over hypotenuse. That now becomes half. Tangent, opposite over adjacent. That's just square root of 3. Because square root of n square root 3 divided by n is just square root of 3. So then when we're finding inverses, sine, or cosecant, is now just going to be 2 square root 3 over 3. Secant, flipping 1/2, is just 2. And then cotan is going to be square root 3 over 3. So what do we notice about?
They're all the same numbers.
They're all the same numbers, just in different spots, right?
Wow.
Does that make sense?
Yes.
So we have one left, 45. So now we're going to go back to the top triangle. Now with the 45, 45, 90, does it really matter which angle you use as your reference angle? Because they're the same, right? As long as you don't use 90, it doesn't matter. So we're going to call that opposite, that adjacent, that hypotenuse. So sine is n over n square root 2. So this becomes 1 over square root 2. But again, I can't leave a radical on the bottom. So square root 2 over 2. Cosine, adjacent over hypotenuse, is also 1 over square root 2. So that's going to be square root 2 over 2. Tangent, n divided by n, 1. Cosecant and secant are both the square root of 2. If you flip 1 over square root 2, you get square root 2 over 1. And then cotan is also 1. If you flip 1, it's 1. Now, the beautiful thing about that is hopefully that when we start to work with the unit circle, I get asked all the time, well, what's the point of knowing this? Well, knowing the unit circle, you can go back and derive those two formulas without even having to memorize n square root 2, n square root 3, 2n. if you would know the unit circle, you can actually go work backwards and find those ratios. Because these ratios come straight off the unit circle. Okay? So we're going to work a lot with the unit circle, and I'm going to be very, very honest with you. Having the unit circle memorized when you get to college calc is arguably one of the best things you can possibly do. Okay? Because knowing the unit circle helps things go so much faster. So much faster. Now, one thing I do want to point out, what this shows. So if we notice, sine of 30 is the same thing as cosine of 60. Right? Cosine of 30 is the same as sine of 60. They're just reciprocal values. They're just opposites, right? We just flip-flop them. And the reason for that is the very last concept we're going to talk about, which is cofunctions. Very quickly, it's literally like I just give you some formulas. What a cofunction means is they are two functions that are 90 degrees apart. Okay? So, for instance, sine of 30 is equal to cosine of 60. The reason for that, and the reason we call it a cofunction, is 30 plus 60 is 90. Something is a cofunction when their values are the same within a 90-degree interval. So 30 plus 60 is 90. That's a 90-degree interval. Those values are the same. That tells us those values mirror each other every 90 degrees. Okay? So if you want to find sine of theta without drawing a triangle, you can use this. Well, if I know cosine of 30, can I find sine of 60? Yeah. I just plug that value in, and I know that they should be the same. Okay? That works with cosine is sine of 90 minus theta. Tangent is cotan of 90 minus theta. Cotan is tan of 90 minus theta. Secant is cosecant of 90 minus theta. And cosecant is secant of 90 minus theta. That's it. Okay. Any questions on that? Good, bad? Again, that's just telling us that every 90 degrees, sine and cosine should mirror each other. All right. The homework 452. Page 288. Numbers 10 through 12. And that's all. 14 through 22. Okay. You've got the rest of class here to work.